Hello everyone, my name is Roy Shilo, co-founder and CTO at PlanetWatchers. In today's presentation, I will talk about the importance of crop lifecycle monitoring and how we at PlanetWatchers derive this information using spaceborne synthetic aperture radar data. The agenda for today's talk is outlined on the slide, starting with the importance of crop lifecycle parameters, following by who may use this information and how, then focusing on the relevance of synthetic aperture radar data and the developed expertise at PlanetWatchers, and closing with a couple of examples from our work. With the increased global demand for agricultural goods, there is a need to output more from every field. For this end, growers and producers are stretching what is possible, and the entire supply chain becomes more sensitive and exposed to unpredictable events. One possible way to mitigate this risk is to create a continuous flow of information on the status of crops along the season, enabling reliable, data-driven, up-to-date decision-making. There are several industries that can benefit from spaceborne crop life cycle information. Today I want to mention three of them: agri-food producers and processors that can use this information to increase the transparency of their supply chains and use it to mitigate risk, the financial sector that can find an edge using historical and timely crop information that is covering large geographies, and insurers that can leverage this information to reduce costs and enable better customer experience in terms of policy, data capture, and for handling claims. I have mentioned in short some of the potential beneficiaries of using crop lifecycle information. Now let's discuss how SAR can help us provide it. It is an active system that generates its own illumination and not relying on the sunlight. These longer wavelengths can see through the clouds. The same wavelengths are also sensitive to the object's structure and texture, making it a very useful tool for monitoring vegetation. You can see in the image on this slide how rich the SAR data is over an agricultural area. In this example on the left, we can see a graphical illustration of the imaging window of SAR, which is basically 100% of the time, compared to the optical with the limitation of sunlight and cloud cover. The illustration on the right presents a visual example of the increased sensitivity of SAR to capture information on the object's structure when compared to the sensitivity of optical imaging. At PlanetWatchers, we have built state-of-the-art SAR analytics capabilities that are effective, fast, and accurate. Our ability to automate the complex workflows involved has enabled us to offer scalable and reliable analytics services. However, it was not trivial to get to where we are now. Analyzing SAR data is complex, starting with the many pre-processing options and workflows, onto the creation and training of machine learning models, and the very large volumes of data involved, as well as the high-performance computing that is needed. The technology challenges are not the only ones we were facing. Working with real clients revealed that often their existing information is not accurate or up to date, and the real-world agriculture scenarios can be complex and hard to model. Those scenarios can also vary between cultures and geographies, creating a challenge that is not easy to conquer. Overcoming these difficulties, we were able to demonstrate top-notch accuracy for crop type classification over very large areas, and we were able to achieve it early in the season, well ahead of crop assessments from other sources. Our results that were field validated support that SAR can be very useful for monitoring planting operations and emergence of crops, as well as other key phenology stages and harvest. In the dates of planting, emergence, and harvest over very large scales, we bring together valuable data points that can be tied together to form a better decision-making process. We would love to hear from you. Thank you.